So previously we have talked about why for an abelian extension L of Q, the conductor of L must divide the discriminant of L. The reason is that if we look at the dual group of the Galois group of L over Q, then the discriminant of L is just gonna be the product of the conductor of all the characters in that group. Whereas the conductor of L is just gonna be the least common multiple of all of those characters. All these discussions might have been a little bit abstract. So how about now we do some concrete computations. So let us take L to be Q adjoint square root of 5 and square root of minus 3. We are gonna compute its discriminant and its conductor using characters. So first thing first, we need to put it inside a cyclotomic field. Now, any cyclotomic field containing this L must contain square root of 5 and also square root of minus 3. But we know the conductor of a quadratic extension. Remember that for the quadratic extension Q adjoint square root of D, its conductor is gonna be absolute value of D if D is congruent to 1 mod 4, and absolute value of 4D if D is congruent to 2, 3 mod 4. So since both 5 and minus 3 are congruent to 1 mod 4, we know that the conductor of both of these quadratic extensions is just gonna be the absolute value of 5 and of minus 3. So we know that these lie inside Q adjoint zeta 5 and Q adjoint zeta 3. Thus our extension L here must lie inside their compositum, which is just the 15th cyclotomic field. So now to compute the discriminant of L and the conductor of L, we need to compute this character group, XL15. Recall that it was defined to be the dual group of the Galois group of L over Q. And since the Galois group of L over Q is just a quotient of the Galois group of the cyclotomic field over this Galois group, this character group here for m equals to 15 is just gonna consist of characters on Z mod mz star that vanishes on this Galois group here. Thus, we need to compute the character group of the Galois group of the cyclotomic extension, and then find those that vanish on this Galois group here. Those are going to be exactly the elements of our character group, XL, 15. And using their conductor, we are gonna find the conductor of L and the discriminant of L. So let us first compute the dual group of the Galois group of this cyclotomic extension. Observe that these Galois groups here are cyclic, so let's call a generator of this Galois group A5 and a generator of this Galois group A3. Now then, the dual group of this is going to be a product of this dual group with this dual group. Z mod 5Z star is cyclic of order 4. Its dual group, viewed as a subgroup of this, is generated by some character chi, sending this generator A5 to a primitive fourth root of unity, which we denote here by this square root minus 1, right? And then fixing A3. Similarly, since Z mod 3Z star is cyclic of order 2, so its dual group is going to be generated by a character chi, sending A3 to a second root of unity, i.e. minus 1, and fixing A5. Since by definition, chi descend to a character on Z mod 5Z star, and psi descend to a character on Z mod 3Z star, we see that they have modulus 5 and 3 respectively. But they do not have modulus 1, so actually they have conductor 5 and 3. And we have that the dual group of the Galois group of the 15 cyclotomic field over Q is gonna be generated by chi and psi. Now amongst those characters, we want to find the characters that vanish on this Galois group. So let us first find what this Galois group is. Okay, so we're interested in finding this Galois group here. Observe that this is just a subgroup of the Galois group of this 15 cyclotomic field, right, that fixes L. Well, an automorphism in here fixes L if and only if it fixes square root of 5 and it fixes this square root of minus 3. So this Galois group here is really the intersection of these Galois groups. So let's figure out what these Galois groups are. Okay, so if we look at the following chain of subfields and then use a Galois correspondence, then we see that this Galois group here corresponding to this quadratic extension here should be of index 2 inside the Galois group of the 5th cyclotomic field, because this is an extension of degree 2. Therefore, it must be generated by A5 squared. On the other hand, this scalar group here must be trivial because this extension here, this q adjoint zeta 3, is actually equal to q adjoint square root of minus 3. The intersection of these two Galois groups inside the big Galois group, the Galois group of the 15 cyclotomic field, is just gonna be A5 squared times the identity. Okay, so what are the characters on Z mod 15Z star that fix this group? Where chi is trivial on A3 and sends A5 to a primitive fourth root of unity, whereas psi is trivial on A5 and sends A3 to a second primitive root of unity. Now an element in this character group is going to be of the form chi to the s multiplied with psi to the r, so it is trivial on this group if and only if chi to the s of A5 squared multiplied with psi to the r of identity is equal to 1. This happens if and only if s is a multiple of 2, if and only if s is an even number. And thus, the subgroup of character that fixes this Galois group is gonna be generated by this chi square and psi. Now, that subgroup has exactly 4 elements: chi square, psi, chi square times psi, and the trivial character. And as we've mentioned, the conductor of chi square is gonna be 5, the conductor of psi is 3, and the conductor of the trivial character is 1. So by our previous discussion, the discriminant of L, the absolute value of it, is going to be the product of all of these conductors, and so it's going to be 5 squared times 3 squared, whereas the conductor of L is just going to be the least common multiple of all of these conductors. And that's just going to be the least common multiple of these two conductors, because this conductor is just a product of these anyway. So the conductor of L is just going to be 5 times 3, i.e. it's 15. And thus, we have made a really good choice for the cyclotomic field to put L in. This is the smallest cyclotomic field that L could fit inside. Okay, so that's an example of how to compute conductor and discriminant using conductor and discriminant of characters on L. That concludes our discussion of class field theory over Q. Up next, we're gonna generalize this for the case of global fields.